Today we are going to see the condition for a rational number to have a terminating or non-terminating decimal expansion. That we are going to see today. In 9th standard you have learnt about rational numbers and their decimal expansion. Okay, so that is a rational number has a decimal expansion which is terminating or non-terminating repeating. Okay, the decimal expansion of a rational number is either terminating, either ending or non-terminating repeating. That we have seen in 9th standard. That is, if we have given a rational number 1.5, here the decimal expansion terminates. So that represents a rational number. Another number say 0.23. The decimal expansion terminates. So that is also a rational number. And again, suppose we are given 0.1666 etc. such a number. That is, here 6 is repeating. Here 6 is repeating. That is, the decimal expansion is non-terminating, not ending, but the digit 6 is repeating. Then that also represents a rational number. Again, another number say 0.23 bar. If it is 0.23 bar, that means 0.23, 23, etc. Here also it's not terminating, not ending, but 2323 repeating. So that also represents a rational number. So a decimal expansion that terminates is a rational number, and if it is non-terminating but repeating, then that also represents a rational number that we have seen in 9th standard. Now today, what we are going in this session, what we are going to do today is we are going to find out the conditions under which the decimal expansion of a rational number terminates or non-terminating repeating. Okay, what are the conditions? That is, without doing actual division for p by q, without dividing p by q, we are going to find out the conditions under which a rational number has a terminating decimal expansion or whether it has a non-terminating repeating decimal expansion. Okay, I shall show by taking some examples. Just listen for that. Here, we just consider the number 1.5. 1.5. We can write it as 15 by 10. Okay, 15 by 10. That is, when we divide a number by, how do we divide a number by 10? We have to move the decimal place, one place to the left. Okay, so when we divide 15 by 10, we will get 1.5. 1.5 equal to, whether we can write it in the form p by q. Now, or we can write it as 15 by 10 raised to the power 1. 10 raised to the power 1. Then, consider another number, say 0.25. It is 25 by what? 100. Two decimal places. So, 25 by 100. 25 by 100. We can write it as 25 by 10 raised to the power 10 raised to the power 2. And consider another number, say 0.144. It is equal to 144 by how many decimal places? 3 places. So 1000. We can write it as 144 by 10 cube. 144 by 10 cube. You see, if the decimal expansion of a number terminates, anyway, it's a rational number, you know. So if the decimal expansion terminates, then we can write the denominators as powers of 10. 10 raised to 1, 10 raised to 2, 10 raised to 3, like that we can write the denominator. Now what are the factors of 10? 2's and 5's. 10 into 2 into 5 into, these are the prime factors of 10. The prime factors of 10 are 2's and 5's. That is, here if the denominator has factors 2's and 5's. 10 means, 10 is the factor of the denominator, means the prime factors of 10 are 2's and 5's. So if the denominator has factors 2's and 5's, then the decimal expansion, here see, terminating decimal expansion. If the rational number has a terminating decimal expansion, then the denominator has factors 2's and 5's. Is it clear? 2's and 5's. Okay, now we are going to check whether both these 2's and 5's are needed as factors for the denominator of a rational number to have a terminating decimal expansion. Okay, for a rational number p by q to have a terminating decimal expansion, is it necessary to have both factors 2's and 5's? Is it necessary to have both 2's and 5's are factors? We can check that. For that, consider the same number. And consider the number 1.5. It is 15 by 10. Now see 15 by 10. Is the number in standard form? Is the number 15 by 10 rational number in standard form? No, because 15 and 10 have a common factor. Which is the common factor? 15 is 3 into 5, 10 is 2 into 5. So that 5 is a common factor to both. They are not co-prime numbers. Co-prime numbers. What are co-prime numbers? Numbers having no common factor other than 1. Here 15 and 10 have a common factor 5. So they are not co-prime. So but here we can cancel this 5, common 5, and we are getting this it as 3 by 2. 3 by 2. Now, what is the decimal expansion of 3 by 2? It is 1.5. It is 1.5. Here, the denominator has only factor 2. The denominator has only factor 2. If you want, we can write it as 2 raised to 1. No 5 is there. If you want, we can write it as 5 raised to 0. Because any number raised to the power 0 is 1. 5 raised to 0 is 1. So 2 raised to 1. But it has actually, when we check the factors of the denominator of 3 by 2, 2 is the only one prime factor of the denominator. So if 2 is the only prime factor of the denominator, then also the decimal expansion terminates. Now again, if we have some 1 by 5, what is 1 by 5? It is 0.2. 0.2, the decimal expansion terminates. Here also it has only, the denominator has only prime factor 5, no 2's are there. So even if the denominator has only prime factor 5, then also the decimal expansion terminates, ends here, 0.2. Okay, so if the denominator has 2's, only 2's as factors, or only 5's as factors, or the denominator has both 2's and 5's are factors, a combination of 2's and 5's, in all the cases, the decimal expansion of a rational number is terminating. Decimal expansion of a rational number is terminating. Then the denominator is of the form, what is of the form? That is, we can write the denominator as powers of prime factors 2's and 5's. Okay, that is, if the denominator, generalizing we can say, if the denominator is of the form some 2 raised to n into 5 raised to m. 2 raised to n into 5 raised to n. What about this n and m? What can be n and m? N can be 0. If it is 5 raised to 0, this m and n can be 0. Okay? Or again 1, it can be 1, it can be 2, 5 square. If it is 1 by 25, 1 by 25, if the number is 1 by 25, we can write it as 1 by 5 square. 1 by 5 square. So that the denominator has prime factors 5 only. If we want, we can write it as 5 raised to 2 into 5 raised to 2 into 2 raised to 2 raised to 0. So that the denominator has factors, we can say 5's and 2's only, 5's and 2's only. So if the denominator is of the form 2 raised to n into 5 raised to m, where m and n are, what are they? They are 0, 1, 2, 3, etc. They are whole numbers. They are whole numbers. Okay, or whole numbers, or we can say non-negative integers. If n and m are non-negative integers, and if the denominator is of the form 2 raised to n into 5 raised to m, okay, then the decimal expansion of a rational number is terminating. Okay, and conversely, if the decimal expansion terminates, then the denominator, that is in p by q, where p by q is in standard form, if q is of the form 2 raised to n into 5 raised to m, then the decimal expansion terminates. In a terminating decimal expansion, the denominator is of the form 2 raised to n into 5 raised to m, And if the denominator is of the form, conversely, if the denominator is of the form 2 raised to n into 5 raised to m, then the decimal expansion terminates. Is it clear? So this is the condition for a rational number to have a terminating decimal expansion. That is, if the decimal expansion of a rational number is terminating, then okay, a rational number p by q, which is in standard form, where p and q are co-prime integers. Okay, then if it is terminating, then the denominator is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. And conversely, in p by q, which is in standard form, where p and q are co-prime integers. If q is of the form 2 raised to n into 5 raised to m, where m and n are non-negative integers, then the decimal expansion of p by q is terminating. Okay. Then again, now we have to consider the case. Another case. If the denominator has some other factor, suppose it has some other factor that is other than this 2's and 5's. If the denominator has some other factor, for example, consider 1 by 6. Now, what is the decimal expansion of 1 by 6? Okay, 0, 1, 6, 4, 40, 6 into 6, 36, again 40, so that again this 6 repeating. So here we have seen that 1 by 6 equal to 0.1666 etc. That is 0.16 bar it is. So 1 by 6 is, so it is a non-terminating, it's not ending, non-terminating repeating decimal expansion. Here see what are the factors of 6. It's 1 by 2 into 6 is 2 into 3. It has a factor 3 other than these 2's and 5's. It has a factor 3 other than 2's and 5's. Then the decimal expansion is non-terminating repeating. Okay. Now consider another number, say Consider another number, say 1 by 15. See the decimal expansion, 1 by 15. O in there, okay. 0. 15 into 6, 90. 10. Again 100, 6, 6, 6, 6. Okay. So here the decimal expansion is 0.66, 0.066 etc. That is 0.606 bar. Here also the decimal expansion is non-terminating repeating. Here also what are the factors of the denominator? 15 is 3 into 5. It has a factor 3 other than 2's and 5's. So if the denominator is not of the form 2 raised to m in n into 5 raised to m. If the denominator is not of the form 2 raised to n into 5 raised to m, then the rational number has a non-terminating repeating decimal expansion. Okay, this is the condition for a rational number to have a non-terminating repeating decimal expansion. That is, if the denominator, if for a rational number p by q, which is in standard form where p and q are co-primes, if the denominator is not of the form 2 raised to n into 5 raised to n, if the denominator has a factor 3, okay, here the denominator has a factor 3 other than 2's and 5's, then the decimal expansion is non-terminating repeating. Now see another example. Let me ask you a question now. Now 1 by 15 we have seen 1 by 3 into 5. The decimal expansion is non-terminating repeating. Now consider the number 6 by 50. What we have to do? Now if we consider the prime factors of the denominator, we will get this is 3 into 5, 15 equal to 3 into 5. Here it has a factor 3 other than 2's and 5's. So what about the decimal expansion? Can we say it is non-terminating or terminating? Now let us check 6 by 15. If we divide 6 by 15, okay. expansion is 0.4. The decimal expansion is terminating. But the denominator has a factor 3. Why? Why it is so? The problem is, here see, 6 is 2 into 3. The number 6 by 15 is not in standard form. 6 and 15 are not, they are not co-prime integers. 6 and 15 are not co-prime, or this is not in standard form. First what we have to do? So first we have to write the number in standard form. If there is a common factor to the two numbers p and q, denominator and numerator, if there is a common factor, first cut it and write the number in standard form. That is, the number is 2 by 5. If we cut 3, we will get 2 by 5. Okay, so that the denominator has only factor 5, no other factor, no factor other than 2's and 5's in the denominator here. So the decimal expansion is terminating. Okay, so before checking, to check whether a number has a rational number has a terminating or non-terminating repeating decimal expansion, what we have to do first? First we have to check whether the number is in standard form. For p by q, we have to check whether p and q have factor or not. First we have to check whether p and q are co-primes. Okay, first check whether p and q are co-primes. Okay, that is, convert the number into standard form. Then check whether the denominator has factors 2's and 5's, only 2's, only 5's, or combination of 2's and 5's. Then, okay, if the rational number has, so consolidating, we can say like this, that is, if the decimal expansion of a rational number p by q, where p and q are co-prime integers, terminates, then the denominator is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. Conversely, if the denominator in p by q, if the denominator q is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then the decimal expansion terminates. And the third point, in p by q, in rational number p by q, where p and q are co-primes, that is in standard form. Then if q is not of the form 2 raised to n into 5 raised to m, if q is not of the form 2 raised to n into 5 raised to m, then the decimal expansion is non-terminating repeating. Okay, non-terminating repeating, that is, if it has some other factor other than, if p by q in standard form and q has a factor other than 2's and 5's, then the decimal expansion is non-terminating repeating. Okay, I think all of you understood today's lesson. Thank you all.